Quadratic applications. One of the most common applications of quadratic functions is projectile motion. When objects are thrown or shot up into the air, they can be modeled with parabolas. So if I have a picture of this guy throwing a basketball, the basketball goes up into the air until it reaches its maximum point, and then it starts to fall. Now, every object in projectile motion is going to fall in the shape of a parabola because they all have the same force acting upon them, gravity. So you're also going to notice several things that they have in common with their functions. They all have the same leading coefficient of -16. Here's example 2, and there's example 3. They all have the same thing, and that is because of gravity. Now, the actual question says, what is the maximum height of the golf ball? Okay, now we need to know what this function is actually talking about. They use h of t instead of y just because it's talking about height as a function of time. And instead of using x, they use t because that is talking about time in seconds. So if we were going to rewrite this problem as y equals -16x squared plus 80x, it is the same thing. Okay, so question A says, what is the maximum height of the golf ball? Okay, so we need to understand what's happening in this problem. They said that the golf ball starts off right here. It starts on the ground. We're at the origin 0 because 0 time has gone by. They hit the golf ball up into the air. It goes up and up and up and up until it reaches its maximum height, so the highest it's ever going to go, and then it starts to move back down until it hits the ground again. So if they're asking us to find the maximum height of this golf ball, what they're actually asking us is part of our vertex. They're actually asking about the y value of the vertex. Now, what we are going to have to do is find the axis of symmetry, because the axis of symmetry has the exact same x value as the vertex. That's why the vertex is on that vertical line right there. And we have an equation for the axis of symmetry right up here. So step 1, we are going to find the AOS, the axis of symmetry. And the equation we need for that is x equals -b divided by 2a. Okay. So obviously we're going to need our a and b values the same way we did when we had quadratic formula, And we would label this with ax squared plus bx plus c so that we can find our a, b, and c values. So ax squared plus bx plus c. Okay, so that means my a value is the number that's attached to the x squared. That would make it -16. My b value is the number that's attached to the regular x, so that would be 80. And my c value is the number at the end that doesn't have a letter attached to it. We don't have one this time, which means that our c value is 0. Okay. So now that we've got that information, we're going to come over here. I'm going to find my axis of symmetry, so I'm doing x equals -b divided by 2a. So all I did is I took the b value, replaced it with parentheses. I took the a value and replaced it with parentheses. So now we can plug those values in. We said the b value on our problem is 80. And on the bottom, my a value is -16. And now we just need to simplify. Go ahead and make sure that this is focused. Okay. So on the top, when you have -80 like that, it only has one negative sign, which means that it is going to stay negative. Now you can also think about this as being -1 on the outside. -1 times 80 is still -80. And on the bottom, if I multiply 2 times -16, I get -32. Now from here, we need to divide. I've got a negative divided by a negative. Double negatives are going to make this positive, and my answer is 2.5. Now, a lot of the times I do have you change decimals back into fractions, but I'm not going to on this one because it is a word problem, and it makes a lot more sense to leave it as a decimal, because what x is talking about is the same thing as t, which means we're talking about time in seconds. So we're saying 2.5 seconds. Okay, here's what that means. That means When they hit the golf ball up into the air, it went up and up and up and up, and after 2.5 seconds, so my time right here would be 2.5, after 2.5 seconds, we have reached our maximum height. So we have the x value right there. Now we've got to figure out what the y value is that would go with it, which would actually be the height. Now what you are going to do is to plug the answer that we just got for the axis of symmetry back into the original equation. Now you can use the h of t1 or the y equals, it doesn't matter to me. I'm going to do the y equals. So step 2. Plug your answer from step 1 into your equation. Now I'm going to use my equation as the y and the x. So I'm using y is equal to negative 16x squared plus 80x. Okay. So what you need to realize right here is that whenever we had 2.5 seconds, that's an x or a t value, which means that we are going to plug 2.5 in place of both of the x's in that problem. So I still have the y equals negative 16, I'm going to put parentheses squared, plus 80 times a set of parentheses. So I just replaced the x's with parentheses. And the exponent does need to be on the outside of those parentheses. Now I can plug in 2.5, just like that. Now I'm going to act as if nobody has a calculator, so I'm going to show you how you would do this by hand first. Okay, when we did PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. Parentheses step means simplify inside parentheses, so we don't have to do that. The next thing would be the exponent. So I would be doing 2.5 squared, which gives me this. And that is attached to the negative 16 right here, so I would multiply it by negative 16, which gives me negative 100. So what I did is I multiplied all of that together, and I got negative 100. Now, if you are lucky enough to have one of the calculators, you can just type that in and see what it is. Okay, on the other side, I've got a positive 80 times 2.5, which gives me 200. And since it is positive 200, I need to put plus 200 right here. Okay, now the y value, if I finish combining like terms, I will have the maximum height. Negative 100 plus 200 gives me 100. And y is actually talking about the height, and the height is being measured in feet. So we're going to say 100 feet. Now to actually make sure that you are answering the right question, go back and read this again. What is the maximum height of the golf ball? I'm going to put over here the max height was 100 feet. Now, whenever you enter your answers onto Canvas, you are not going to worry about the labels, the feet, all that stuff. I only care about the number. Okay, so now let's do part B here. Part B says, how long will it take for the golf ball to reach the ground? Okay, so what we're doing now, we already found the maximum height. The highest it went was 100 before it hit the ground again. It hits the ground at the x-intercepts. So one of them is going to be at 0, and the other one is going to be how long it took for that golf ball to hit the ground. Okay, now we are looking for the x-intercepts, and what we are going to do is use the quadratic formula. That helps us find the x-intercepts. So that means I've got x is equal to negative b plus or minus the square root of b squared minus 4ac, this whole thing divided by 2a. Now I like to rewrite that so that I can show you what's happening between steps. I'm going to put negative my b value with a set of parentheses, plus or minus the square root. I've got b squared right here, so I'm going to put a set of parentheses squared, minus 4 times my a value and my c value. This whole thing is divided by 2 times a. And now what we need to do is use those A, B, and C values that we found on part A, and plug them back into part B. Now I'm just going to rewrite them right here so that you can see them while I'm doing the notes. We said A was negative 16, B was 80, and C was 0. I got all of that information. Let me wait for it to unfreeze. I got all of that information from what we did right up here. Okay, so now we need to plug in some values. Okay, now the first letter that goes right here is your B value. That's got to be 80. Right here, I have B squared again, so that would be 80. And then I have my A value. Well, my A value is negative 16, and my C value at the end right there is 0. On the bottom, I've got 2 times A, which means 2 times negative 16. So now what we need to do is simplify this quadratic formula. So I'm going to come over here, make my new bar. When I have negative 80 like that, if it's only got one negative sign, it stays a negative number. So I've got negative 80 plus or minus the square root. Now inside my square root, I have 80 squared. So I'm going to start off by doing 80 squared just like that, which gives me 6,400. And if I multiply over here, negative 4 times negative 16 times 0, whenever I hit enter, I end up with 0, because multiplying by 0 is always going to give you 0 for an answer. So I could put plus 0 right here and do another step where I put them back together, but I'm going to go ahead and leave it like that. And on the bottom row, I am doing 2 times negative 16, which gives me negative 32. Now, if you like to go ahead and break your problem apart from there, that's okay, but I always like to check and see if this is actually a perfect square. What I mean by perfect square is, can I take the square root and get a whole number? Something that's not a perfect square would be like that. If I took the square root and I got a decimal, then I would have to leave that. But since I got a perfect number, 80, I can go ahead and add in another step right here where I do this. I've got negative 80 plus or minus the square root of 6,400 was 80. Okay, and this whole thing is divided by negative 32. Okay. So now that I've got it like this, I am going to go ahead and break this apart into its 2 separate problems. We're breaking up the plus or minus sign. Now, I'm going to do the positive one first. So negative 80 plus 80 over negative 32. Or it could be negative 80 plus, or sorry, not plus, minus. This time we're doing minus 80. Divided by negative 32. Okay, so if I'm going to simplify this right here, on the top row, I have negative 80 plus 80, which is 0. So what I've got is 0 over negative 32, which is just 0. Now on the other side, I have negative 80 minus 80, which gives me negative 160. So on the top, it's negative 160, and on the bottom, it's negative 32. Now I need to finish dividing right here. We're doing negative 160 divided by negative 32, which is 5. Okay, so we got 2 answers here. We got 0 and we got 5. Now the 0, that is our x-intercept. That's our starting point right here. The 5 was how long it took for that parabola to hit the ground. So here's just the picture. I put the numbers on there so that you can see it. It went up, it reached its highest point at 100, it came back down, and it hit the ground again after 5 seconds. So make sure that you are actually answering the right question. It said, how long will it take for the golf ball to reach the ground? We'd say it hits the ground after 5 seconds. Now, once again, when you are entering those answers onto Canvas, do not worry about putting the labels like seconds or feet or anything like that. I just want the number.